Hi, welcome back to Tech Tricks Info. Today we'll be explaining about the working of a torque converter. I have already uploaded a video in YouTube on the working of torque converter and also another video on torque multiplication, and those videos I explained with the help of a cut section, a real torque converter there. But here we'll be concentrating more on the theoretical working because some of my friends have commented that the working was not exactly clear to them. So I'll be getting more into the details of its theoretical working. So let's see how it exactly works. What's the purpose of a torque converter in an automobile? In automobiles we have a torque converter, or in the place of torque converter we use clutch. So in manual transmission vehicles we use clutch. Clutch actually is a mechanical linkage between the engine. So here we have the engine and this is the gearbox. So it's a mechanical linkage between the engine and the gearbox. And torque converter replaces the clutch in automatic transmission vehicles. So in torque converter we don't have a mechanical linkage in the case of a clutch, but it has a hydraulic linkage which transmits the power. So exactly there is no mechanical connection between the engine and the gearbox in a torque converter as in case of a clutch. So let's see how exactly it works. This is our engine here and this is our flywheel. So you can see that this is the torque converter over here, which is mounted towards the flywheel through bolts. Okay, so here we have our torque converter exactly here, and this is the gearbox. So we need to transmit our power which is generated in the engine, which reaches the flywheel, to be transmitted towards the gearbox. Let's see how we achieve that. So this is our torque converter, and consider that this torque converter is filled with fluid. So here we will be having fluid inside the torque converter completely, and the torque converter exactly comprises of three main components. One is the turbine, other is the impeller, and the third one is the stator. So let's see where these components are coming. So imagine that this unit is completely filled with oil or the fluid. Okay, so we have the impeller opposite towards the engine. So this is our impeller. Okay, so this is our impeller, right? It has vanes like this over here, and this is a part of the casing itself. So this is our casing, and this impeller is fixed towards the casing itself. So it's a part of the casing itself. So when we have fluid inside and when the engine is working, when we look from the rear side, a flywheel will be rotating in the anti-clockwise direction like this. So flywheel rotates in anti-clockwise direction. That makes our torque converter also to rotate in the anti-clockwise direction. So as we have the fluid inside, this impeller will work like a centrifugal pump. So here you can see the vanes of the impeller. It's a front view of the impeller. So we have vanes here, and when the fluid is hitting here, it will be pushed outside like this. Okay, through these vanes to the opposite direction. Okay, so the fluid will be pushed outside and it comes and hit over here, the face of the torque converter, this section. Okay, so this is our impeller, right? Then we have the turbine. So the turbine will be coming somewhere like this. This is our turbine. Okay, so I am drawing the turbine right now so that you can understand how the turbine, where the turbine is located and how the turbine exactly works. Okay, so here we have the turbine. Turbine is actually floating inside the torque converter. This turbine does not have any mechanical linkage inside the torque converter. So impeller is a part of the torque converter and turbine is a separate unit. It's floating like this. Okay, and the third unit is our stator. Okay, let's talk about it later. So we have an output shaft from the turbine, okay, to the center portion. This is the portion. So we have an output shaft from the center of the turbine. It passes through the center of the impeller and reaches the gearbox. It reaches the shuttle reverser of the gearbox, and that's how it takes away the drive. So as I have explained, the fluid comes from the impeller like this, okay, and comes and hits our turbine. So this fluid comes and hits the turbine. As the turbine is free inside the torque converter, which is just connected using this shaft, will start to rotate. Okay, our turbine will start to rotate. So that's how the power coming from the engine actually reaches the gearbox, because when our turbine starts to rotate, as this shaft is connected to the turbine, the drive will be taken away by this shaft towards the gearbox, and the gearbox transmits that through the propeller shaft to the rear wheels. So that's how the drive is being taken away. Okay, but we have an issue, because when this flow is coming and hitting the turbine, and it reverses through the turbine, so the flow comes from the impeller, hits the turbine and reverses from the turbine and go back towards the impeller. Okay, it goes back to the impeller in the opposite direction. That means this flow moves in the opposite direction of the vanes of the impeller. So what really happens is that flow will hit the impeller, and there is a chance to slow down the impeller, because it is coming and hitting in the opposite direction of the vanes. When a flow is coming and hitting the opposite direction of a fan, it can slow down the fan. So the same is happening here in the case of impeller. So we need to avoid this opposite flow which is going and hitting the impeller. So what we do is that we have the stator to play a role over there. So this is our stator. The stator comes in between here. Okay, our stator will be coming here like this. Okay, stator has vanes like in the opposite direction towards that of the turbine. So the flow will now be redirected through the stator only. The stator again reverses the flow coming from the turbine and allow it to enter the impeller in a positive direction. So stator will be located in the center part, and the flow will actually get redirected through here only. This is the channeling way of the flow. Okay, so this flow which is getting channeled through the turbine enters the stator, and the stator again reverses the flow and allows it to enter in a positive direction towards the impeller, which will not slow down the impeller actually. So that's how it continuously works. So this torque converter is a fluid coupling which has these three main components: the turbine, the impeller and the stator. The impeller works like a centrifugal pump, as I told, because it's a part of the casing itself. As it rotates due to the centrifugal force, it works like a centrifugal pump, and it throws the fluid away towards the opposite direction, which comes and hit our turbine. And the turbine, which is internally connected through this output shaft towards the gearbox, takes this flow and rotates and takes the power through this output shaft towards the gearbox. So that's how the power from the engine, which is reaching the torque converter, I mean the impeller, it is taken away by the turbine and through this output shaft reaches the gearbox and the rear wheels. And the flow which is coming in the opposite direction, which is coming back from the turbine towards the impeller, is routed in a positive direction by the stator. This is a one-way clutch and it can only rotate in one direction. So that's how a torque converter exactly works. So this is used in automatic transmission vehicles. So if we have a torque converter, we doesn't have to use this clutch pedal. There won't be any clutch, because even we apply the brake, the tire stops, the gearbox stops, this shaft, this output shaft from the turbine stops and our turbine stops. But still the engine can rotate, because the fluid will slip inside the torque converter and will not transmit the load from the gearbox or from the rear tires, which is stopped, towards the engine. Because of the simple reason is that this is not mechanically linked. If we use a clutch, that cannot happen. We need to press the clutch pedal, otherwise the gearbox will be mechanically linked with the engine and it will stop the engine. But here in this case, exactly, this turbine will be stopped, but as the turbine is not mechanically linked with any of engine components, it is only floating inside the torque converter. So it becomes stationary, but still the torque converter will rotate and the fluid will slip through the turbine, which will not transmit the load back towards the engine. So that's how simply a torque converter works. So if you have more doubts, post a comment, and you can also go into and see our torque converter and torque multiplication video. The links are been shown in this video, so you can get a better understanding of that. If you like this video, please click the like button and do subscribe to us for more technical videos. Thanks for watching this video. Have a great day.